package we have. For the first few, there's a couple of questions that are fairly similar, so I'm just going to do lengthy explanation for the first one, and then I'm going to go through the next one really quick. All right, so question A, we're asked to convert from angles, degrees into radians, and express it as a simplified fraction. So to turn an angle in degrees into radians, we multiply by pi over 180 degrees. And the reason for that is because 2 pi is equivalent to 360 degrees, so it's a similar fraction. We reduce it to get pi over 180. And so when we do so, we check to see what can be simplified. And I can see that we can divide them both by 10 to begin with, so I'll cross those zeros out. And so that gives us 22 pi over 18. And I can see they can both be divided by 2 as well. And that gives us 11 pi over 9. And that cannot be simplified further. But in case I wasn't sure, a backup is I could put that into my calculator and use my fraction button in my calculator and just see how it simplifies. And it says it simplifies to the fraction 1 and 2/9. I'm going to turn that into an improper fraction. And improper version of that is 11 over 9. 11 over 9. Neat. Okay, cool. That's 1A. 1B is a pretty similar question. We have 305 degrees. So we're going to multiply that by pi over 180 degrees. Again, and I don't know what I can do here, but I can think they can both be divided by 5. So I'll divide 305 by 5. I get 61. And I'll divide 180 by 5, and I believe that gives me 36. And so then I get 61 pi over 36, and I think that 61 is prime. But just to check, I'll just ask my calculator if that can be simplified further. And it cannot. It just is written as 61/36. All right. Now, to go from radians back to degrees, which is question 2A, we're looking to turn 15 pi by 9 into a number of degrees. Okay, well, 15 pi by 9, or to go into degrees, we just do the opposite here. We multiply by 180 degrees over pi. When we do so, we cancel out the pi's, and I can see these can both be divided by 9. So that leaves us with 20 degrees up here. And so it looks like most things cancel out, and we end up with whatever 15 times 20 is. 15 times 20 is, of course, 15 times 2, which is 30, plus that extra 0, which gives us 300 degrees. Okay. Question 2B. We get the fraction 8 pi over 11, and we're going to do the same thing. We're going to multiply by 180 degrees over pi. First thing is the pi's cancel out. No common factors between 11 and 180. 11 is a prime number, and it does not go into 180. So overall, we're just going to get a fraction. It's going to be 8 over 180, or 8 times 180. And that whole thing, 1440 over 11 degrees. I'm going to find out what that is, how many degrees that actually is, divided by 11. I get 130 degrees. Okay, that sounds good, because this is a little bit less than pi radians, or all the way around, so not 11 elevenths. Okay, so I think they're both in the second quadrant. Okay, I can picture that. All right, moving on. Then we have some basic solve problems. Now we have a few different flavors of these solve problems where we have to, sorry, it's not really a solving question, we're just really evaluating. We're finding out what the value of each of these trig ratios is. So we'll start with cosine of 7 pi by 4. Cosine of 7 pi by 4. So the first thing we should do with a question like this is we should graph it in standard position. And of course I start by labeling these guys up. Pi 3 pi by 2, and 2 pi. And I know that 7/4, 7/4 of pi is almost up to 2, but it's not quite. And a little trick I can do if I'm not sure is I can rewrite these as having denominators of 4. So I can call that 2 pi over 4. I can call that 4 pi over 4. I can call this, multiply the top and bottom by 2, I get 6 pi over 4, and 8 pi. 2 pi over 1 becomes 8 pi over 4. And that helps me see that 7 pi by 4 is actually exactly halfway between 6 pi by 4 and 8 pi by 4. So here's my angle, 7 pi by 4. And that means we have a pi by 4 reference angle to get from 7 pi by 4 to 8 pi by 4. Right? 1 extra pi by 4. And that's a special triangle, right? So we'll draw in our special triangle, and we'll say, okay, well, that's our 1, 1, root 2 triangle. So it's 1 here and negative 1 there, and root 2. We've got to remember that's a negative direction here. And we're going to take the cosine, which is the 1 over the root 2. So the cosine of 7 pi over 4 is just 1 over root 2. And for full marks, we'll just multiply or rationalize the denominator, root 2. This that becomes root 2 over 2. And there is our answer. Okay. Next we have question B, which gives us a tan of negative 3 pi by 2. Okay. So 3b, the tan of negative 3 pi by 2. So the first thing we want to do is graph it. And if we graph negative angles, they graph in the negative direction. So we'll just label up our axis here. And that's negative pi by 2, and negative pi, and negative 3 pi by 2. And there we go, actually, there's our angle. It actually just terminates on the axis. So that is our angle, negative 3 pi by 2. Now, when an angle terminates on the axis, we need to think about the unit circle, right? So I could just draw a little version of the unit circle out. I'll label up. You don't actually have to go ahead and label all the points, but it's definitely helpful to label the point that terminates on the same axis you're on, which is this one, 0, 1. I'll just label the rest. Oops. Negative 1, 0. I guess that's wrong. 1, 0, and 0, negative 1. Okay. And so tan is always the y value over the x value in this unit circle, because it would be the opposite over the adjacent. X, y. So y and the x, and the opposite would be the y value here. And so we take the y over the x, which is 1 over 0. And that is undefined. You cannot divide by 0. So we say this is undefined. You could also say DNE. That would be okay as well. Okay, moving on, we have question 3C here. So 3C gives us the ratio of sine of 0.75. Now, 0.75, that means 0.75 radians. And as you might remember, 1 radian is equivalent to around 50, gosh, I always forget this off the top of my head. 180 divided by pi, 57.3 degrees. So that means that 0.75 radians is probably, well, it's 0.75 of that. It's 43 degrees, roughly. So we can picture that being in our first quadrant, right? So there's our 0.75 radians, where, of course, this is pi radians, which is the same thing as 3.14 ... radians, and a pi by 2 up here, which is, of course, equal to half of that, right? So it's equal to 1.57 ... radians. and 0.75 is in the first quadrant. This is not a special triangle situation, so we're just going to use our calculator. Oh, no, I'm in degrees. Make sure I'm in radians. And oh no, I think this is hard to do. Okay. No, stupid thing. Okay. I don't want to clear mode. All right. Oh, there it is. Dumb. Okay. I mean, I really want to turn this into. Well, this isn't exactly useful footage, so. Sine 0.75. All right. Well, fine. I'll just get another calculator. There we go. And we want radians, so we're going to go just down to radians like so. All right, sine 0.75. Oops, that was a mistake. Sine 0.75. Fat fingers. All right, so we get sine of 0.75 is equal to, it's approximately equal to 0.682. And we'll call that. And that's with a calculator. All right, so last question in this section, which is D, cosine of 11 pi. Okay, so for 3D, first thing we want to do is graph that thing. Where is 11 pi? So I know that 2 pi is all the way around. So we'll go all the way around. That's 2 pi. I also know that if I go another 2 pi, I can go another way, all the way around. 2 pi, 4 pi, 6 pi, I can keep going. 8 pi, 10 pi, and so that's like 4 pi, 6 pi, 8 pi, 10 pi, but I can't go a whole other way around. I have to go halfway to get to 11 pi. So that makes this 11 pi axis. Okay, and that terminates on the axis, right? So we know from our unit circle that the cosine value always corresponds to the x-coordinate. And so the x-coordinate of this point is -1. And so the answer to this question is just -1. And we can confirm that with a calculator, right? Oh, no. Unless we have radians. Cosine of 11 pi is -1. Okay. So moving on. We're going to find a positive and a negative coterminal angle of 21 pi over 5. So the first thing we should do again is graph this angle. So this is 0, pi over 2, pi, 3 pi by 2, and 2 pi. And I can write pi as 5 pi over 5, and I can write 2 pi as 10 pi over 10. That helps me see how to graph this thing. That means I have to go 10 pi by 5. Oh, sorry, that should be 5. 10 pi by 5. And then another 10 pi by 5 to make 20 pi by 5, plus pi by 5 more. And that reference angle there is pi by 5. That's from here to here. And that whole angle is 21 pi over 5. Okay. So we can say, so we're asked for any positive coterminal angle. So one positive coterminal angle would have been to go 2 pi around, or 10 pi by 5 plus 1 more. So some answers, I think I spelled that wrong. One answer could be, these are possible answers. So one could be that minus 2 pi from here, so we could get 11 pi over 5. But we could keep going, and we can actually say just that reference angle also terminates there. So another good answer would be 11, or pi by 5. Alternatively, we could start here and go all the way around backwards. So get negative 5 pi by 5, and go almost all the way around. That would be negative 9 pi by 5. Now, you could, as long as you're adding 2 pi each time, you can get any number of answers. But as long as you added some number of 2 pi, some integer number of 2 pi's, you're going to get to a coterminal angle. So we got one positive, one negative. All right. Let's get on to some of the harder stuff. So question 5 asks us to solve a trig function. Okay. So we're asked to solve the equation 2 pi cosine theta is equal to negative 1. So the first thing we end up doing with these questions is we isolate the trig ratio. So we're going to isolate the trig ratio. And we get cosine theta is equal to 1 over root 2 negative. All right. And we got to figure out, well, what quadrants could those be in? So we have this principle of all students take calculus, right? Where all the trig ratios are positive here, but only the sine ratios are positive here, which means a negative cosine could live here. Only tan ratios are positive in this quadrant, which means a negative cosine ratio could live in this quadrant. If they're all positive, a negative cosine ratio couldn't live here. And C stands for cosine, meaning all positive, or pardon me, all cosine ratios are positive in this quadrant. So that means we could be in quadrant 2 or quadrant 3. Okay, 2 and 3. All right, cool. So we'll sketch those guys out. We'll say, okay, well, possible angles terminate out here and terminate out here. So we'll just label our triangles up here. So our possibilities are that our adjacent has to be negative 1. Those are adjacent over our hypotenuse. Our hypotenuse always has to be positive, so negative must be associated with the adjacent. Hypotenuse is going to be root 2. All right. That looks like a special triangle, right? That's our 1, 1, root 2 triangle, which makes this angle pi by 4 and pi by 4. Of course, that means these two angles, theta 1 and theta 2, so theta 1 looks like it's pi short pi by 4, so we're short pi by 4. So if you take a quarter of pi away from a whole pi, you get 3/4 of pi. And the other angle is pi by 4 greater than, oh, sorry, that should be pi, not theta. Weird. Theta 1 should be pi plus pi over 4. That equals, should be minus. Oh my gosh, guys, sorry. I am a little tired, but I don't really have that as an excuse. I'm just being dumb. I'm not that tired. All right. Pi, take away pi by 4. That's theta 1. And that gives us 3/4 of pi. And theta 2 is pi plus pi by 4. And that gives us 5 pi by 4. All right. So, moving on, question B. Oh, and of course, because we are only looking for angles between 0 and 2 pi, those are only 2 solutions. And we can test those solutions, right? We can test it, we can plug it back into the original question if we wanted to. And this is an important skill. So we can test if we want by saying, okay, well, what happens if I take root 2 times cosine 3 pi by 4? Is it equal to -1? Let's try it. Square root root 2 times cosine of 3 pi by 4 equals -1. So we got -1 is equal to -1. That's true. And that's how we can tell that that's one of our angles of theta. Okay. All right, so on to 5b. And 5b suggests that we're trying to find an angle theta that's such that the ratio becomes undefined when we're done. All right. So our trig ratio is isolated, but we have to figure out where could an angle be so that tan is undefined. So we remember that we get undefined values from the unit circle when we divide by 0, right? So I'm going to label up all of our unit circle points. Well, I'm going to do it correctly this time. Wrong. Okay. So this is the point 1, 0. This is point 0, 1. This is the point -1, 0. This is the point 0, -1. And we have to remember that tan is always equal to y over x. And that is undefined. So therefore, x must be 0. Okay, so which points have an x value of 0? Well, the angles pi by 2 and 3 pi by 2 have angles with x values of 0. So our two angles are pi by 2 equals pi by 2 and or 3 pi by 2. And I can just test that if I want. So we'll just try one. So tan of, let's say, 3 pi by 2 equals undefined. And tan of 3 pi by 2. Get a little bit of glare there. And I get a domain error. Yeah, so undefined equals undefined. True. Okay. So we'll move along. So the next question looks like it's going to involve some factoring. So 5c, we got 2 sine squared theta minus sine theta minus 1 equals 0. So we're going to, looks like a trinomial here, right? That looks a lot like you can imagine this statement. So we're going to try to factor this expression out. So really, we're looking for two numbers that add to the middle term here, so the coefficient of the middle term, which is a -1, and two numbers that multiply to give us the product of the first coefficient times the last coefficient. That gives us -2. So we're looking for two numbers that add to -1 and multiply to -2. And I think those numbers are -2 and 1, and -2 and 1. All right, so the next thing we do is we split that middle term. So instead of writing it as -1 sine theta, we're not really changing the first term or the last term at all. In fact, most of the expressions kept the same. Instead of -1 sine theta, I'm going to write it as -2 sine theta plus 1 sine theta. Take away 1. And if you were to group those like terms, you would find you get negative sine theta there. I'm going to split those guys in half. I'll bring in a common factor here, which is 2 sine theta. And I'll bring out a common factor here. There isn't one, so I'm just going to write plus 1. That's all equal to 0. And inside here, I'm going to get, I guess, sine theta, take away 1. And same thing here, sine theta, take away 1. Those are common factors, so they're going to be factored up to the front. And when we do that, we'll get that sine theta, take away 1 in front here, and 2 sine theta plus 1. Those are the leftover terms. Cool. So it looks like we have two different scenarios here. We have the scenario where sine theta is equal to 1, and another scenario where 2 sine theta plus 1 equals 0. Or, in other words, I can simplify that. So 2 sine theta is -1. So that means sine theta is equal to -1/2. All right, so those are two potential avenues to find the angle that makes this whole statement true. I'll start with this one. This looks like a unit circle question. And so we get 1, 0 here, 0, 1, -1, 0, 0, -1. And sine is always a y coordinate. So when y value is 1, well, that looks like it's going to be the angles 0, pi by 2, and 3 pi by 2. I said 0 just because I was labeling. I didn't actually mean that was one of the solutions. And so we get these two solutions from this part of our question. We get that theta could equal half of pi or 3/2 of pi. Okay. Here we get a negative sign ratio, so we go to our all students take calculus scenario, and we say, okay, well, all ratios are positive here, so it's not here. Our sine ratios are positive here, so it can't be up here. Tan ratios only are positive, which means we can have a negative sign, and cosine ratios are positive here, so it means we could have a negative sign. So we got these two other possible solutions. So we'll draw out the sketch, and of course this is an opposite over hypotenuse, right? So the opposite side has to be -1, because the hypotenuse has to be positive, and then it'll be 2. So that means we're going to get two angles here. One gives us an opposite of 1 and a hypotenuse of 2, and the other also gives us an opposite of -1, pardon me, and a hypotenuse of 2. Now that is probably already making you think that we have these special triangle scenarios. And the angle in here, well, that looks like it's going to be pi by 6. Pi by 6. And, of course, 3 pi by 2, 2 pi. So that means we're going to get two other angles here. So we're going to get an angle that is pi plus pi by 6. Says 6 pi by 6 plus pi by 6, or 7 pi by 6. And theta is also 2 pi short we're short pi by 6 from 2 pi, so we're going to subtract pi by 6. And that's going to give us 11 pi by 6 when we're done. So overall, theta is, I usually like to go from smallest to biggest, so pi by 2, 7 pi by 6, 3 pi by 2, 11 pi by 6. And there's our answer to question C. All right. Then we'll do question 5D. So 5D, 4 sine squared theta, take away 3 is equal to 0. So we'll add 3 to both sides. We've got to isolate our trig ratio. So we get 4 sine squared theta is equal to 3. Divide by 4, divide by 4. We get sine squared theta is 3/4. Of course, we got to isolate our trig ratio, so we got to get rid of the squared. And so we get sine theta is equal to plus or minus the square root of 3/4. And to make it easier for ourselves, we can distribute the root to both of those expressions. So we can say that's plus or minus the square root of 3 over the square root of 4, which is 2. And so really that means we have two different possible solutions. We have the scenario where sine theta is equal to positive root 3 over 2, or we have where sine theta is equal to the negative root sine 3 over 2. And so those two solutions together, so this one tells us we could be looking for solutions if we think about all students take calculus in this quadrant or this quadrant, but not these two. And this one tells us we're looking for negative sign ratios, so it can't be in this place where they're all positive. It can't be where the signs are positive. So what this says, in other words, is that there's going to be a solution in each quadrant. So sometimes in the solutions we've done, we've found them separately, but there's nothing wrong really with using one big axis, 0, 2 pi, to draw out all the possible solutions. Now, as a reminder, we're talking about sine ratio, so that means opposite over hypotenuse, opposite over hypotenuse. And so we're going to draw out our angles, call that theta 1, and it's going to have an opposite of root 3 over 2, hypotenuse. So that looks like a special triangle. That looks like a 1, 2, root 3 triangle. I haven't really drawn it to scale, but that's pi by 3, right? So I'm going to try to draw the other ones a little bit more to scale. I didn't really succeed there. It's still kind of almost isosceles in nature. And so that means our reference angle here is pi by 3. As we continue along, try to make that one a little steeper. Looking a little bit more to scale, we've already labeled this side to be negative 1. This is negative root 3 and 2 here. And lastly, we have this last angle here, which is has again an opposite side of root 3 and a hypotenuse of 2, a side of 1. And these all have the same reference angles. Okay, so I can say theta 1 is really just my reference angle. It's just pi by 3. Theta 2 in my second quadrant here, that's going to be pi radians, but we're going to subtract that pi by 3, which of course is 2/3 of pi. Angle 3 is going to be pi plus pi by 3, which of course becomes this 4 pi by 3. And angle 4 is 2 pi take away pi by 3, which is 5 pi by 3. So our angles are pi over 3, 2 pi by 3, 4 pi by 3, and 5 pi by 3. Okay. So, moving on, we've got question 6 here. And question 6 asks us to determine the exact values of theta when we're all real numbers of theta. So that's a little different than this question, which asks us only to find solutions within the first rotation, which asks us to express a general solution. Okay, so first we'll solve, okay, so we know that a negative cosine, students take calculus, so it's not going to be here. It could be here in the positive sine quadrant, and it could be here in the positive tan quadrant, and it can't be here. So we're going to have two angles here in these quadrants, and of course we're going to be looking at all of their coterminal angles as well. Alright, so I'll draw a little sketch here. Of course we know for cosine theta to be equal to -1/2, that means we're going to have an adjacent of -1 and a hypotenuse of 2. And so that means when we draw out our angle here, we're going to have an adjacent of -1 and a hypotenuse of 2. I don't know if that -1 was too small. Something bigger there, -1. Okay. And that means that this side must be √3 and -√3. That's a special triangle as well. It's the angle π/3. And so we're going to call that θ1. Call this guy here θ2. Alright. So we're going to get us one solution. θ1 is, of course, 2/3 of pi. And then you can keep getting to this angle every time you add 2 pi. So plus n 2 pi's. And θ2, we could say is going to be 4 π/3 plus n 2 pi's. Now we have to define what n is, because it could be any kind of number. We have to state that you can really choose any integer in the world. So formal solution should be, you could have 2/3 of pi plus any number of 2 pi's you want, or 4 π/3 plus any number of 2 pi's you want. You have to specify that n belongs to the integers. So that is to say that it can be any counting number. So if I can choose -5 for n, crunch the numbers, and I'm going to get one value that terminates on one of these two angles. And therefore, if I take the cosine of that angle, the adjacent of the hypotenuse, it's going to give me -1/2. Okay. So we're asked to now get into some graphing here. We're asked to state the amplitude, period, phase shift, and vertical shift, or vertical displacement. Okay, so the amplitude, that's always equal to the absolute value of our A, which is equal to the absolute value of √3, which is 3. Okay. Our period is always equal to 2 pi divided by our B value. So we're going to get our B value in this case is 6, so it's going to be 2 pi over 6. So that means we're going to simplify that to pi/3. So it's going to repeat itself every third of pi. The phase shift, to read the phase shift, we actually have to make sure we factored this out. So we actually have to rewrite this. Y equals -3 sine of 6 x. We have to make sure we divided this into sixths, and so that actually makes it pi/12 when we divide it by 6, plus 8. So that is our phase shift. So our phase shift is pi/12 units left. This direction. All right. Oops. And our vertical displacement is always just equal to d. So it's just 8 units up. And that's it. Simple as that. So we'll do a similar question that this one involves a graph. Room here on this question page. All right, so we're going to look at this graph for question 8. Now, we approach it slightly differently if we don't have an equation. Of course, we could write an equation to this graph pretty easily. So the amplitude is the vertical distance from the midline, which looks like it's 3 in this case, up to 5, or the vertical distance down to 1. So our amplitude there looks like it's going to be 2. So our amplitude equals 2. All right. Our period is the distance from peak to peak, like that. So how far did we go from 5 pi by 6, or from pi by 6 to 5 pi by 6? Well, intuition suggests we go 4 pi by 6, right? But maybe we can prove that to ourselves. So for our period, so what we could do is we can just say, okay, well, what is 5 pi by 6 take away pi by 6? 5 pi by 6 take away 4 pi by 6 is equal to, oops, subtract pi by 6. They have the same denominator, so we're just going to subtract the numerators. We're going to get 4 pi by 6, which simplifies to 2/3 of pi. Now, another way to see that is to see that starting at your y-intercept, you end up at the same position on this graph in the midline when you're heading upward here. And during that period, you've actually passed 2/3 of pi. And so that's another way to answer that question. So our amplitude is 2, period is 2/3 of pi. Our phase shift depends on what kind of graph we think this is. Now, I see this graph starting in the middle and kind of increasing, which is pretty traditional of a normal positive sine curve. And if that's the case, it hasn't really been shifted left or right at all. So if it's a positive sine curve, our phase shift is 0. However, if it's a cosine curve, that means an original cosine curve, positive cosine curve, would have started here and then had been shifted to the right, pi by 6. So if a positive cosine curve, the phase shift is pi by 6 to the right. Okay. And lastly, our vertical displacement, and is always equal to our baseline, right? It's just 3. It's very simple. And our vertical displacement d equals 3. All right. Oops. Moving on. We're getting there, guys. We are almost there. So question 9 asks us to sketch 2 periods of this function. So to do that, we're going to need to know, so I'm just going to grab the pen I just dropped. We need to know all the features that we can about this thing. So I'm going to piece this apart. I'm going to say, okay, well, the first thing I know is that the amplitude is 3. My period, I'm going to need to know my period. And looks like it's going to be related to 2, of course. 2 pi over 2, which is pi. So it's going to repeat itself every pi units. For my phase shift, I'll have to factor that out, of course. So it's going to be y equals 3 cosine 2x minus 1/4 pi. And so that means that my c value is pi by 2, 4. And so that means we're going pi by 4 to the right. And lastly, our vertical displacement is -1. Okay, so I would start a question like this by sketching out an axis and labeling it up. So first thing I'm going to graph is the point -1. And that's my baseline, right? Because it's my vertical displacement. So I'm going to do a little dashed line there. It's not part of the graph, so I don't use a solid line. But it is helpful for me, so okay. And I know my amplitude is 3, so I know I'm going to go as high as 1, 2, 3 units up, so that's going to be my maximum height. I'm going to go as low as 1, 2, 3 units down, so it's going to be my minimum height. And so I know I'm going to oscillate between these maximum and minimum values. And so that helps me localize, organize myself. All right. So the next thing to do is to say, okay, well, my period is pi. So I know it's going to repeat itself every pi units. So I'm going to maybe label pi. Oops, 2 pi, and we'll say 3 pi. Cool. And the last thing is that I know that I have to shift pi by 4 to the right. So what I'm going to do is I'm going to divide this pi, this period, into quarters. And that helps me when I need to shift it a quarter of a unit to the right. Okay. That's most of the things I want to start with, and it kind of helps me. I've got my framework here. And, oh, right, I need to know it's a cosine graph, right? So cosine graphs, positive cosine graphs, they start at the top of their amplitude, right? And so this graph would normally start all the way here at the top of its amplitude and decrease, but it's been shifted to the right. So it's actually going to have a position here, and that's going to be my first point on my curve. And I know that it's going to repeat itself every pi unit, so I'm going to have another point there, and another point here, and another point here. And I also know that halfway in between two peaks is a trough, so that's going to live down here, halfway between, right? And you can also think of it as having been halfway between 0 and pi, and then shifted pi by 2 to the right. And, oops, so I'm going to repeat that point every pi units, because that's my period. My period is pi. And halfway between the peak and the trough, I'm also going to pass my midline. So halfway between pi by 4 and 3 pi by 4 is half of pi. I'll hit a midline there, and I'll hit the midline here. It looks like every quarter of pi, I'll hit a midline. No, that's not right. Sorry. Quarter of pi past a peak or trough. Past a peak, quarter of pi, I'll have a midline value, and so on. And so it's looking pretty spiffy at this stage. Of course, it kind of looks almost like a zigzag saw line or something. So the last thing I need to do is I need to bring my knowledge of trigonometric sinusoidal functions to know that they actually have like a curved nature to them. And so while you could connect these dots with a zigzag, we have to know that's not really how these curves tend to work. So we're going to draw a curve that connects them. Like so. And that looks like it's 3 periods and then some, so we did a little bit extra. Okay. See, I actually find it's easier to draw this graph when you aren't given a labeled axis, because then you can kind of choose your own way to divide it in terms of how you're going to label it. And that actually, I find, makes it a little bit easier. Okay, so there's our curve. All right. So, you know what? I think I'm going to stop this video here and to avoid the risk of this thing freezing before I've done all this work, and we'll pick up the next.